Okay, so problem 6.27, it says derive the equivalent for a series connection of ideal capacitors. So draw these capacitors in series. We know that capacitors in series our equation for capacitors in series looks like this. So this question says to denote initial voltages as V1 T naught. So here, V2 T naught. The sum of voltages across the string of capacitors. Okay, so and we know that by KVL that the total voltage is the sum. The total voltage in a closed circuit is the sum of the voltage drops, right? So V1 plus V2. Okay. It says derive the equivalent circuit for a series of ideal capacitors, assuming each capacitor has its own voltage. Right. So we know that, say we have a current here, we're going to call it I. You know that the equation for capacitor I is equal to the capacitance times the derivative of the voltage across the equivalent capacitor. So here we have two voltages, right? So okay. So then yeah. Well, the integration of across these capacitors with respect to time would look like this. And this isn't minus. And this is the equivalent. So yeah, it says derive the equivalent circuit for the series. So yeah, essentially what I think this question is trying to ask is to derive this, right? Okay.